Right. In 4.5, we're going to be graphing sine and cosine curves. So this is what the graph's going to look like for a sine function. It's important to know that the sine graph always starts at the origin. Now, if we have shifts being applied to our graph, this might change, but your sine graph's going to keep this shape. It's going to start at 0. It'll go up to the amplitude, back to 0, go down to the amplitude, and then back to 0. So it'll keep this curved shape. From 0 to 2 pi, this here is 2 pi. This is one period of our graph. Now this is kind of a reflection of the unit circle. Sine tells us we look at what on the unit circle? The x or the y? The y. So looking at our unit circle, at 0, our y is 0. If we then go to 2 pi, our y is 1. If we go to pi, our y is back to 0, so we're back at 0. At 3 pi over 2, our y is negative 1. And then when we go back to 2 pi, we're at 0. So these values correspond to the unit circle. So we're not really dealing with the unit circle. We're just going to be graphing it. So cosine, similar. It still has that same curve shape. However, cosine is going to start at the amplitude. So it's going to start up top. Then it will go back to 0, down to negative 1, to 0, and then to 1. So we're going to be graphing sine and cosine. The difference between the two is just going to be where they start. Everything else, when we find the period of the graph, when we find the increments, the tick marks, any shifts that happen, it's all going to be the same. The only difference is going to be where it starts. So sine graphs start at 0. Cosine graphs start at the amplitude. The domain of the sine and cosine functions is a set of all real numbers. That's because our graph is going to go forever to the left and forever to the right. It keeps going, even though we're just going to be graphing one period of it. And then the range is from negative 1 to 1. Our height is going to oscillate between negative 1 and 1. But this might change if we have different transformations happening to it. So this is just for our basic graph. And then each function is going to have a time period of 2 pi. We're just going to be graphing one period, but again, if we have transformations, this will change. So here it puts the sine and the cosine graphs together. So the first one is our sine graph. It starts at the origin. Second one is the cosine graph. It starts at the amplitude. We have some more just basic information on this page. I'm going to skip this one. We'll come back to it, and let's look at this. We're going to talk about our transformations that are happening. So anything that's getting multiplied in front of our sine or cosine, this is the same for sine and cosine. So anything that's getting multiplied out front of our trig function is going to be the amplitude. So that's going to be how high and how low our graph's going to go. It's the range. Anything that's getting multiplied directly to the x is our b. That's going to help us find the time period, which is 2 pi over b. It's also going to help us find our starting point. We take c and divide it by b to find the starting point. This is where we start. But looking at the equation here, notice how it's minus c. So we always want to change the sign of c. Here. So it's whatever we're adding or subtracting to the x, but you change the sign. And then whatever we're adding outside is going to be our vertical shift. If we're adding something, we're going to shift our graph up. If we're subtracting something, it gets shifted down. So it's going to move it up or down. But that we're going to save for the very end. So if we do have a shift up or down, that's going to be the very last thing that we'll put on our graph. So starting with example 2, it says on the same set of coordinate axes, sketch the graph of each function by hand. So we have 1/2 times the cosine of x and 3 times the cosine of x. So starting with the first one here, I'll start with the 1/2 cosine x. So we have our A, B, C, D. For every graph, I want to find the starting point. I'm going to find the period, and I want to find the increments. So A is what gets multiplied out front. What would our A be here? 1/2, awesome. B is what gets multiplied to the x. What's getting multiplied to x here? What would our coefficient of the x be? 1. Awesome. There is no coefficient, so it's just 1. Now C is what gets added inside to the x. Is anything getting added inside? What do you think C would be then? 0. And then D is anything that gets added outside. So what do you think our D would be? 0. So even though for B, nothing's getting multiplied to the x, we still put 1 there because we have an x. If it was 0 times x, we wouldn't even have an x, but there's a 1 as our coefficient in front of the x. But there is nothing that's getting added, so those two would get 0. Now to find our starting point is going to be C over B. What's our C? 0 over B, we said is 1. What's 0 over 1? 0. So this is going to be where we start at 0. So our graph's going to start at 0. For our time period is 2 pi over B. So that would be 2 pi over 1, which would just be 2 pi. So the length of one period of our graph is going to be 2 pi. The increment is the period divided by 4. So what was our period? 2 pi divided by 4, so that would be pi over 2 when we simplify. So for our graphs, we always want the starting point and 4 more points. So our starting point is going to be at 0. And I need 4 more points after it. So 1, 2, 3, 4. To find what our next point is going to be at, our next increment, we just keep adding the increment. So here I would add pi over 2. We add the increment each time. So then I add another pi over 2, add another pi over 2 for the next tick mark, add another pi over 2 to the next tick mark. So what's 0 plus pi over 2? Pi over 2, perfect. What's pi over 2 plus pi over 2? 2 pi over 2, which would simplify to what? Pi, perfect. So our next tick mark would just be pi. Then I'm going to add another pi over 2. What's pi plus pi over 2? 3 pi over 2, awesome. So this one would be 3 pi over 2. And then what's 3 pi over 2 plus another pi over 2? 2 pi, perfect. It'd be 4 pi over 2, which would simplify to 2 pi. So these are going to be our increments. Our amplitude is our A. So that's going to be the height of our graph. So we're going to go up to 1/2 and we're going to go down to -1/2. So the amplitude is just going to be the top and the bottom boundaries. Once we have our increment and our amplitude, we can put our graph. We can graph it. So we have a cosine graph here. Where did we say that cosine is going to start? It starts at the amplitude. So it's going to start up at 1/2. And then at each tick mark, we're going to have a point. So my next point is going to go back to 0. You're not going to go any higher than your amplitude or your negative amplitude at the bottom. So you're just going to bounce back in between these. So I go to 0. At the next tick mark at pi, I'm going to go down to -1/2. Then I'm going to go back up to 0 when I'm at 3 pi over 2. And then we're going to go back to 1/2 when we're at 2 pi. So our graph is going to look like this. Now when you're cutting your graph, so this is just like it's one period of our graph. But if we were to keep going, it would keep this same shape. But when you're cutting the cosine part of it, it kind of looks like a V, even though it's got that curve. When you're cutting the sine part of it, so if I had a sine graph, it starts at 0 and it goes to here. It's kind of got a little bit more of a curve shape, but it's just because it's a different piece of the graph. Here we're just cutting it at the top for both the left boundary and the right boundary. So it just looks a little bit different, but cosine is going to have these 5 points. For B, when we have 3 cosine of x, everything stays the same except the amplitude changed. So instead of going up to 1/2, I'm now going to go up to 3 and down to -3. So for our cosine graph for this one, we're going to start at the amplitude, go back to 0, then to our negative amplitude, go back to 0, and then up to our amplitude. So this one's going to look like this. So the only thing that changes between A and B was the amplitude, which is just going to be how high and how low your graph goes. So for every graph, you're going to want to find your starting point, which is going to be C over B, your period, which is 2 pi over B, and your increment, which is going to be the period divided by 4. So for every graph, you need your starting point and 4 more points. Now, we can multiply our graph by a negative out front. If you do have a negative in front of your trig function, so negative that's being multiplied out front, it's a reflection over the x-axis. So it just flips your graph upside down. So if I had 3 cosine, we said it starts up at the amplitude, goes to 0, negative amplitude, 0 here. So this would be our 1 period of the graph. If we multiply by a negative, it all just flips. So instead of going and starting at the positive amplitude, we'd start down at the negative amplitude to 0, then we go to the positive amplitude, back to 0, then down here. So it would just be the same graph, but it flips upside down. So let's look at example 4. We want to graph 1/2 sine of x minus, this got erased, but it should be pi over 2. So just like before, we're going to graph it. I want to find my A, B, C, D. We need the starting point, the period, and the increments. What's our A? 1/2, that's our amplitude. So that's how far we're going to go up and down. So we're going to go up to 1/2, down to -1/2. What's our B? What's getting multiplied in front of the x? 1. What's our C? Pi over 2, perfect. Since it's a minus pi over 2, remember we changed the sign for the C, so it would be positive pi over 2. And then what's D? What's getting added on the outside? 0. Nothing's getting added on the outside, so D would be 0. So let's start with the starting point. What's the formula we use for our starting point? C over B. So our C would be 1/2 over B, which is 1. So that would just be 1/2. So our graph gets shifted, so it's going to start at 1/2, at pi over 2, sorry, pi over 2. How do we find the period? Two pi over B. And what's our B? 2 pi over 1. So our period would be 2 pi. And how do we find the increments? The period divided by 4. So 2 pi over 4, which would be what? Pi over 2. So we have our starting point, and we're going to need 4 more points after it. So to go to my next tick mark, I need to add an increment to it. So I'm going to add pi over 2. So whatever the increment is, that's what we're going to add. We're going to add another pi over 2. To get to the next one, add another pi over 2. To get to the last one, we're going to add another pi over 2. So starting with the next point after our starting point, what's pi over 2 plus pi over 2? Pi, perfect. It'd be 2 pi over 2, which would just be pi. Then we're going to add another pi over 2. So when we add another pi over 2, what do we get? 3 pi over 2. When we add another pi over 2, what do we get? Perfect. It'd be 4 pi over 2, which would be 2 pi. And then when we add another pi over 2, what do we get? 5 pi over 2. So you just keep adding pi over 2. Add whatever your increment is to get to the next tick mark. So for our sine graph, now that we have everything on our graph, let's put the graph on it. For a sine graph, where do we start? We start at 0, but I'm going to start at my starting point at 0. So we're going to start here at pi over 2 comma 0. Where do we go next? Up to 1/2. So we're going to go up to the amplitude, back down to 0. Where do we go next? Down to negative 1/2, and then back to 0. So our graph is going to look like this. Let's do the last one here. So same thing, I want to find my A, B, C, D. We need the starting point, the period, and the increments. So what's our A? A is 3. Our amplitude is 3. That negative out front tells us we're going to have what? It's going to flip. It's going to be a reflection. But the reflection we're going to save for the last thing. I'm going to graph everything as if it were positive, and then I'm just going to flip it at the end. What is our B? 2. Awesome. B is what gets multiplied to the x, so that is 2. What's C? Negative pi over 4, because you have to change the sign, because in the formula it should be minus C. So we flip the sign, so it'd be negative pi over 4. And then what's D? 0. How do we find the starting point? C over B. So our C is negative pi over 4 over B, which is 2. What do we do when we have a fraction in a fraction? Keep, change, flip. We're going to keep the top, change to multiplication. We'll flip 2 to 1/2. So what do we get for our starting point? Negative pi over 8. Perfect. So I'm going to put that on our graph here. So we are going to start at negative pi over 8. So that's going to be to the left of our y-axis that we have. So we're going to start at negative pi over 8. I'm also going to put my amplitude while I'm at it here. So we're going to go up to 3 and down to negative 3. How do we find the period? 2 pi over b. So 2 pi over our b was 2. So 2 pi over 2 would be what? Pi. And then how do we find our increment? The period divided by 4. So that would be pi over 4. So we're going to add pi over 4 to get from one tick mark to the next. So starting with our starting point, we have negative pi over 8 plus pi over 4. What do we need? A common denominator. So I'm going to make this 2 pi over 8. So negative pi over 8 plus 2 pi over 8 would be what? Pi over 8, perfect. So since that's positive, I'm going to make it on the positive side over here. So we have pi over 8. Now we need 3 more. So I'm going to add another pi over 4. Again, we need a common denominator, so I'm going to make it 2 pi over 8. What do we get when we add 2 pi over 8? 3 pi over 8, perfect. So we have 3 pi over 8. We're going to add another pi over 4. We're just adding our increment each time. So I'll make that another 2 pi over 8. What do we get next? 5 pi over 8. So then we have 5 pi over 8. We're going to add another pi over 4. Then I'm going to make 2 pi over 8 again to give us a common denominator. What do we get? 7 pi over 8. So we have our starting point and 4 more points. Any questions here? All right, let's put our graph here. So we have a cosine graph. Cosine tells us that we start where? At the amplitude. So if this was a positive cosine graph, we'd start up at the positive amplitude here. Our next point, we go to the next increment, which would be at 0. Then we would go down to the negative amplitude, back to 0, and then up to the positive amplitude. So this would be what our positive graph looks like. But we have a negative graph. We said that we were going to have a reflection. So what do we do when there's a reflection? We flip it. So instead of starting at the positive amplitude, we're going to start down at the negative amplitude. Then we go to 0 at our next tick mark. Then we go back up to the positive amplitude, back to 0, down to the negative amplitude. So our graph looks like this. I'm going to erase the orange one because the orange one would be if it was a positive, just to give you a visual of what it would look like positive. But this one's a negative cosine graph, so we had to flip it. So we had to apply that reflection. Be super careful here. A common mistake that people will make is that they'll put a point at the origin. The origin at 0, 0 is not one of our increments, so you can't put a point there. But people love to put an extra point at the origin for some reason. So just skip over the origin. We don't need to put a point there. You shouldn't put a point there. It just goes on your tick marks. So super, super important is how you need to be able to identify your A, B, C, and D, and then knowing how to find your starting point, the period, and the increments. So you need to know these formulas here.